So we just proved, we're still on angles and angle relationships, and we just proved that two lines were parallel if you used the slope formula. And now we're trying to prove if two lines are perpendicular. Now, a key thing and the differences between if two lines are parallel and two lines are perpendicular is that perpendicular lines, their slopes are actually multiplied to equal to a -1. So let's look down here. It says the slope of perpendicular lines. In a coordinate plane, two non-vertical lines are perpendicular if the product of their slope is a -1. Now, this diagram here shows two lines that are perpendicular. The way that we prove if those lines are perpendicular is if their slopes are equal to a -1. So, example, the slope of line 1 is a -2 and slope of line 2 is 1/2. So -2 times 1/2 is a -1. Therefore, we could say that these two lines are perpendicular. Now let's look at example number 1. The question says, are the lines perpendicular? And remember, the way that we prove that is we use the slope formula. Then we take both the slopes from both lines, multiply them together, and see if both slopes equal a -1. So let's look at line number 1. Here I actually, I went ahead and I labeled them for you. So the red line is line 1 and the blue line is line 2. So first we're going to find the slope. So let's go up here. Now remember, our slope formula is y2 minus y1 over x2 minus x1. So line 1, our points were at 0, 3, and 3, 1. And line 2, our points were at -4, -3, and 0, 3. So I just took those from here. Now, let's find the slope of line 1. So here we go. So I used y2 minus y1. So y2 minus y1. So 3 minus a -3. And 0 minus a -4. So two negatives make a positive, two negatives make a positive. So the slope of line 2 is 6 over 4, which is 3 over 2. Now let's look at line 1. So line 1, our points are 0, 3, and 3, 1. So 1 minus 3, 1 minus 3, and 3 minus 0, 3 minus 0. So our slope is 1 minus 3 is -2, and 3 minus 0 is a positive 3. So the slope of line 1 is -2 over 3. Now, let's go down here. So the slope of line 2 was 3 over 2, and the slope of line 1 was a -2 over a positive 3. Now, let's go back to our definition. Our definition says that two lines are perpendicular if their slopes multiply to equal a -1. So let's multiply them and see what they equal. So 3 halves times a -2 over 3. 3 times a -2 is a -6, and 2 times 3 is a positive 6, which comes out to a -1. So we can positively prove that those two lines are perpendicular because their slopes multiply together to equal a -1. Now, let's go down to example number 2. So again, the question is find the slopes, multiply the slopes because we're trying to prove if the lines are perpendicular. So let's kind of zoom in here. So line 1, or actually, I'm sorry, let's do example number 3. I actually didn't do example number 2. So you need to do example number 2, and I will do example number 3. So it says, are the lines perpendicular? Now, our example up here, we used our graph. We had a graph. Down here, we don't have a graph. We have two formulas, and we need to turn both of these lines into the y equals mx plus b form. So let's do that first. So line R, we have 4x minus 5y equals 2. We need to turn it into y equals mx plus b, which is the slope-intercept form, as you can see here. So I minused 4x from both sides, and I got 5y equals 2 minus 4x. I want y by itself, so I divide by 5, divide by 5, and you get y equals 2/5 minus 4/5 x. Our formula is y equals mx plus b, so we need to switch these two. So we get y equals a -4/5 x plus 5. Now the slope here is a -4/5 x. So then let's look at line S. Line S is 5x plus 4y equals 3. So let's go ahead and write that out. 5x plus 4y equals 3. We want y by itself, so I subtract 5x from both sides, and I get 4y equals a negative 5x plus 3. I divide by 4, and you get y equals a negative 5/4 x plus 3/4. So my slope for line S is a negative 5/4. And my slope for line R was a negative 4/5. So we're going to multiply them together. So a negative 4/5 times a negative 5/4 is 20 over 20, which is 1. Therefore, the product is not a negative 1. Therefore, R and S are not perpendicular. Okay? All right. Now let's look down at example number 4. It says line T1 has the equation of y equals a negative 1/4 x plus 10. We want to write now the equation of a perpendicular line. So it says find an equation of the line T2 that passes through a negative 2/3 and is perpendicular to T1. So again, if T1 and T2 are perpendicular, then our slopes, both of our slopes have to equal a negative 1. So m1 times m2 is a negative 1. Now we know that the slope of T1 is a negative 1/4. So therefore, if we multiply by 4 over 1, we're going to get a negative 1. So the slope of line 2 has to equal 4. And these are our points. So now we're going to go ahead and we're going to plug it in. And we want, remember, y equals mx plus b. We want to solve for b. So we know our 2 points. Our 2 points are negative 2 and 3. And our slope is 4. So let's go ahead and plug in. So y equals mx plus b. Our y was 3. Equals, our slope is 4. Our x was a negative 2 plus b. So 3 equals 4 times negative 2 is negative 8 plus b. We're going to add 8 for both sides, and our b is 11. So now we can go ahead and plug in. Y equals mx, which is 4x because our slope was 4, plus 11 because 11 is b. So that is our equation. So go ahead, and I want you guys to go ahead and do example number 4 and example number 2.